can see it.
Not on this one. Say yes.
What is it?
You mean it? Okay. I get what that is.
You know all her close friends?
Okay, let's go. Okay, so starting today, everything is term 3. So no more items on term 2. The only way you can change your term 2 grade is if you decide to turn in. So you can earn tally marks between now and the end of the term, and those tally marks can be used either on term 2 or term 3. You get to choose. So that's the way you can improve your grade for term 2. If you're planning on retaking, you can still do that for term 2, but no more assignments on term 2. Okay, don't do this packet yet. Don't do the packet yet. We're going to use some of the information on the packet for the discussion, but don't do the packet until I tell you. This new unit, if it feels like what we are talking about initially is pretty simple and easy to understand, that's good. Just don't check out. Like, don't go, oh, this is so easy, I don't even have to listen. Okay, because when it switches to complex, the switch will occur very rapidly. Okay, and if you haven't made sense of what seemed really, really simple, the switch is impossible. If you're following along and it's feeling good and comfortable, then that's perfect. When we have to go to complex, the step will be really easy. Just make sure you're not checking out when it seems really simple, okay? Okay, the table on the page in the packet describes an airplane. For our class, things don't ever move in complex ways, just always straight lines. So this airplane simply moves in a straight line, okay? A couple of key things to notice is, because the velocity, a bunch of this is review, it's not new, just kind of connecting what you've learned with something new here in a minute. Okay, every value of the velocity here is positive, which means the plane is always moving to the right. So as I've done before, I'll kind of act out the motion of the plane. This spot in the center of the room is known as the origin. It's not time 0, it's not where the plane starts, it's just location 0 on a line. So locations over here will have negative values. Locations over here on the right have positive values. Questions? So that's not new. We've done this before. Okay, so just kind of reviewing a little bit. If I write down that S of 0 okay, first of all, who remembers what the symbol S of 0 means? What's the symbol S of 0 mean? Let's go, Marin.
The position at time 0.
Perfect. Unit 4, how many do that? 42 for Marin. Okay, we're in Unit 4 now. The test for Unit 4 occurs kind of end of January. The test for Unit 4 is written. No multiple choice, all written questions. So you've got to make sure you, as I've been emphasizing all year, use good notation. The test is written, you will be judged on your notation, not just your answers. So, the thing you get judged on for the Unit 4 test is actual units. So it's important that you keep track of the units in the problem. In this particular case, we're going to be measuring time in minutes and position in miles. So the units of the 0 are minutes, but the units of this entire symbol, these units are meters. I keep saying that miles, sorry. Okay, so the position is measured in miles, and as Marin said, this is saying the position when time is equal to 0 would be whatever it is. So a couple of lines into the packet, there's a statement that says, we'll say that S of 0 is 10. So this would be 10 miles. Okay. Questions? Okay, the word miles can have different meanings. In this particular case, this is referring to a specific spot along the line which the plane travels. So if I'm now standing at the origin, this would indicate a spot like right here, like 10 miles to the right of the origin. That's a specific location. It's saying that at time equals 0, this is where the plane is. It's right here. Okay? Cool. A little later in the packet, it also says this. S of 40 is 234 miles. So just because saying it does help you remember it, somebody raise your hand and tell me what this says. Josh?
So position at time 40 is 200.
Good. So this again is referring to a specific spot. It's a little hard for me to act out that spot because I guess I could say this is 10, and then this would be about, it's not too bad. This is about 234. So this is location 234. Questions? Okay. If you've had physics, the next word you hear won't be new. If it's new to you, no big deal, just memorize it. You have to understand for the AP test what is meant by displacement. Okay. So we're always digging for understanding here. Somebody said something really insightful yesterday. I'm going to give two tickets for this one. So Calvin doesn't even remember that he said it. Okay, he said, no, really, you said really something very insightful. You said that sometimes you think what goes wrong with, like, when you miss a test question is that there are concepts in the question that when you were doing the homework, you asked someone for help, and they helped you, and you're like, oh, I got it, now I do this. But the trouble was you didn't really, this is what you told me, is you didn't really take the time to know why you were doing it, you just did it. That's extremely wise advice for all of you, okay? In this class, if you do something and you don't have a reason, don't do it. Like, come talk to me until you know the reason. Another caution. I've also had people tell me, well, here's what I did. And the reasons they give are, in their mind, logical, but none of the reasons they gave me we ever talked about. Like, they're making up reasons. Don't do that either. You're not going to be successful, okay? You have to follow the reasons we talk about. So look over here. Okay, when you see the word displacement, all of you, so how many feel like they know what displacement means from previous class? Almost all of you, good. Okay, when you see the word displacement, your brain should immediately say, oh, that's not enough. I can't talk about displacement without knowing some additional information. Like, what additional information is needed to discuss, like, the word displacement alone doesn't mean anything. Like, it has to have some other information associated with it. I see all the time that I'm trying to get you to not do what I do, but think how I think. So what am I thinking here? Hands, come on, whole room. When I look at the word displacement, when I think of the word displacement, what other information is essential to even continue the conversation? Like, the word displacement alone doesn't really mean a whole lot. Just read the name for me.
Ainsley and Anglin.
Thank you. Good job, Stephen. Hands up. Come on. Who knows what I'm thinking? Goal this class not to do what I do, but think how I think. What else am I thinking here? Chris?
Is it like that? It's like the difference between two different things. Like,
No, well said. Well said. I can't talk about displacement unless I know the time period. Like displacement doesn't make any sense to be just displacement. It's like displacement over some time period. So in this example, I'm thinking, okay, let's talk about the displacement from time equals 0 to time equal 40. So how many knew I was thinking that? 0.2 for good. So hands up, what is the displacement from time equals 0 to time equal 40 for this example? Just hands up. What's the displacement from time equals 0 to time equal 40 in this example? I'll write this down here. Okay, Justin.
Is it 224 miles?
So the displacement over this time period is 224 miles. Because displacement simply means how different is my new position from my previous position.
Does displacement show direction?
Good question. Hold on a second. How many knew this before he said it? 0.2 for Justin. Okay, I want everybody to think about Carson's question. Okay, Carson's question is a really good example of if we just think about it in a common sense way, we'll know the answer and then we'll never forget it. Like way better than just memorizing a fact, right? Like make common sense of the idea. So, hands up. Who believes that it would make sense for displacement is telling us how different is my new position from my old position? So raise your hand if you can tell me, should displacement be negative or just always positive? Hands up. Just think about it in a common sense way. If displacement is supposed to tell me how different is my new position from my previous position, would I want displacement to have a negative value or just always be positive? Think of it in a common sense way. So,
Positive.
tell me why.
Just because it's how far you are like away from your starting point. So
Let me say something back to you. You're really good. 3 points for Sophie. Listen, I like your thinking a lot. Sophie said, well, it tells you how far away you are from your starting point. You want to change the wording just a little bit. It's better to say displacement tells me, like, how different is my new position from my previous. Not necessarily just how far. Like, how is my new position different than the previous? So hands up again. You want displacement to be positive, negative, or both? And why? Koji?
Positive,
Tell me why.
because I don't like thinking like absolute value is always positive.
Absolute value is always positive, but we haven't necessarily said displacement should be absolute value, so don't.
I'm just thinking like because the difference between those 2 points is still 10, like or 224, even if you're moving backwards or
3 points as well. There's a key thing that no one's picking up on yet, at least they haven't said it. Okay, listen to the definition again. Displacement's going to tell us how my new position is different than my old. Is there a reason for displacement to ever be negative, or should displacement always be positive? It tells you how different is my new position from my old.
But it could be negative because, like, isn't when it's like going left, it would be like a subtraction, and so it could be negative in that sense. So you know it's going left when it's negative, right?
So example, 3 for Sydney. Look at me. Okay, in this example, the plane is at location 10, and then 40 minutes later it's at location 234. So knowing the displacement is 224 tells me I moved from where I am to the right 224. Like, that's my change in position. The negative is actually important because I need a negative to reflect that, well, what if I ended up changing my position in that direction? So the idea that it could only be positive is not necessarily wrong. But somebody long ago decided, no, we want to keep track of both. We want to know, did the particle's position alter itself in one direction or the other? So displacement absolutely can be positive or negative. Absolutely. Displacement can be positive or negative because it has to tell you, where's my new position relative to my old? I have to have the ability to say it's positive or negative is different. Anyone want me to talk more about that until it feels more like common sense? Please.
So would it only be negative if it's left of the origin? Kind of like,
Oh, everybody listen to, no, these are really good questions. 2 for Chris. I want everyone to answer this one as well. Okay, we've said displacement can be negative, for sure. Displacement can be negative. I can have a situation where my new position is left of my original position, okay? Does displacement being negative have anything to do with, I don't know how to say that. If my displacement is negative, do I end up left of the origin? Hands up. If my displacement is negative, does that mean I will end up left of the origin? Rachel?
You don't have to. Like, it's just, like, if you move left from the, like, point it was asking about.
Yeah, let's say, we know that at time equal 40, I'm at 234, right? So I'm way over here. Let's just pretend that 10 minutes from now, I'm now at, let's write this down. So let's say, it's not in this information, so we're just making this up to answer the question. Let's say at time equal 50, I'm now at location 200 miles. So I started here at time 40, then in 10 minutes I'm here. So I'm still right of the origin, but my displacement during those 10 minutes was negative 34. Questions? 2 for Rachel. So displacement can be positive or negative, and a negative displacement doesn't necessarily mean I'm over there. It's just how is my new position different than the previous. That's it. Please.
Could you say like displacement is always like the final minus the final minus the initial?
Yes, for our class we will always define displacement as final position minus initial position. Initial and final can be whatever. Like we just did one here where we said, you know, my initial position is time equal 40, 234 miles. My final position is time equal 50, 200 miles. So it doesn't have anything to do with time equals 0 necessarily. 2 points for Josh. Somebody else. Cool. So that's displacement. Key to success is to always write equations. So I want an equation for displacement. Like what should be written here when we're talking about displacement. Okay. I need an equation. Displacement is what? Maybe
S of F minus S of I for initial.
Perfect. I'll just write it in the words to make it clear, but it's perfect. Exactly. So that's not really necessarily math symbols, but it does convey the right idea that I want to find the difference between my final position versus initial position. That's displacement. So for Elena, question? Awesome. Okay. Look at these 3 values. Let's do this. Let's say displacement.
Is there an abbreviation for that?
For displacement?
Yeah.
I wish. I've never seen them use any sort of symbol on the AP test for that. They just use the word. But I've never seen them actually require you to write displacement equals or anything, so that's okay. You could use, like, the tricky part about it is because displacement has to involve some time period, it's hard to have like one symbol that tells you what's going on. I sometimes might write this. I'll say delta S, the change in position over some time period. Something like that, but not really any standard symbol. Hands up, who knows what number goes here? Show me your hand. So show me your hands, what number goes here? See everybody raise their hand. What number belongs here? What number belongs here? Ashley and Ainsley are having a debate over there, so that's good. Tori and Abby as well. What number goes here? Oh, that would help. She's like, I don't even know what you're asking. She was standing there in front of me. So, Abby, what is it?
190 miles.
How many had this? 20, 2 for Abby and 2 for Kennedy, so you can see what I was doing. We want to talk about it? Okay. Again, we're not trying to learn what I'm doing. We're trying to understand what I'm doing. Okay. So here's a good test of your understanding. I've got all these different numbers on the board. This says 10 miles, 234 miles, 200 miles. This says 190 miles. This says 224 miles. There is a distinct difference between the meaning of the word mile here, here, and here, versus the meaning of the word miles here and here. Raise your hand if you can tell me the difference. Like, what's the difference between the word miles in this application versus the word miles in these two applications? They are totally different meanings. Totally different. What is the difference in their meaning? Let's go, Charles.
There's 3 of them. They're like just the position, like 10 miles away from the origin, and then the displacement is like the difference from those 2 positions. So it's the space.
That was, hold on. Yeah, that was good. No, that was you need to be a lawyer. No, Charles, really well said. Really well said. These are, I won't be able to say it as good as Charles did. You said that very well. These are these are specific locations. Like, to really talk about what these are, I need a picture, and I need to be able to say, oh, here I am at a specific spot, which happens to be 10 miles from the origin. It's a specific location. When you got to here, you did exactly what I would do. You took your hands and went like this, because this is a difference. It's how different is one location from another. This spot is only right here. It's nowhere else. This difference could be who knows where. It could be from here to here. It could be from, way over here to here, that sort of thing. It's perfect. How many knew before you said it? Point. Okay. Questions? Okay, awesome. We talked about how displacement can be positive or negative. So we can use the value of the displacement to figure out whether the particle, object, whatever, airplane, ended up moving to the right or to the left. In this example on the board, there's another key parameter they will ask you about. So we just said the displacement over the entire 50 minutes is 190 miles. Because that's how different the final position is from the initial. Raise your hand if you can use your common sense to tell me what's another computation they might ask you to make with these numbers. Like, they might want another piece of information that relates to how this plane is moving. Come on, hand. It's a common sense thing. Like, what's another common sense thing? Oh yeah, you figured out the displacement, go figure out blank as well. It's associated with these numbers. What's the blank we're thinking of? Let's talk to each other so we get more points given. I'd like to give away some more points. Hands up, come on, hand. Don't ever take points if you're not raising your hand. It's how I judge how well the class is doing. Lizzie.
The slow?
2 points for that. Hands down for a second. They will absolutely have questions where they want to know that. They want to know not only, like these are referencing positions, like where the particle is. They'll want to know how fast the particle's position changes, which is slow, for sure. It's not what I was thinking of, but nothing wrong with the answer at all. What's another thing they'll want? Apparently everybody was thinking slow. How many were thinking slow? Wow. 2 points for the whole room, 3 for Lizzie. What I was trying to get you to think of, hey, look up. No, it's very good. Look here. Look here. There is something you can calculate using these 3 numbers. Okay, these 3 values that they'll probably ask you for. Probably not a very good question, Mary.
Oh, I was thinking how fast the plane's moving.
2 points for that. That is related to slope as well. The thing they're going to ask you for is if the plane actually does start here and it only goes to the right for the first 40 minutes, which that's what we see happening as far as we know, and then the plane comes back to the left for the next 10 minutes, they will also likely ask you to figure out the total distance that the plane travels. So now to find this, okay, look, okay, displacement is not tricky. Displacement is just a comparison between 2 locations. So if I know the plane starts at position 10 miles, and 40 minutes later the plane is at position 234 miles, it does not matter what the plane did in between. The plane could have done whatever. It has no effect on my calculation of the displacement. Displacement is only concerned with where was the plane, forget about what happens in between, where is the plane? That's it. You need me to say that again. Okay, however, distance traveled is much more complex. Why? Hands, come on. Why is displacement is a much simpler concept than distance traveled? Like, what's the complexity of finding the total distance traveled versus finding displacement was really easy?
Because you have to find all of the distance that it traveled, whether positive or negative. So you have to find all the distance that it traveled.
Very good. So if I start here, and then in 50 minutes, I'm here. If all I care about is displacement, I don't care what happened in between. But if I need total distance traveled, I've got to keep track of how I got there. Like I've got to say, okay, I was here, and we'll assume for the first 40 minutes I only went to the right. Only to the right. And then we'll assume that for the next 10 minutes I only went to the left. If that's true, hands up, what's the total distance traveled? Come on. Calculators are allowed in this unit, by the way, so if you want to have your calculator out, it's fine. Calculators are allowed in this unit. What is my total distance traveled? Talk to each other, get more hands up. Come on.
So you minus
Hands up, come on, what's my total distance traveled? What's my total distance traveled? Let's go, Kylie.
258.
Tell me how you found it.
So I took the displacement from S of 0 and S of 40, and then found the displacement from S of 40, S of 50.
So, Kylie, let me say it back to you. You're doing absolutely spectacular. It's what I wanted to hear. Because we said that we are assuming that from time equals 0 to time equals 40 minutes, the plane only moves to the right. Then to get from a location of 10 to a location of 234, plane must have traveled 224 miles to do that. Hands up if you made sense of that before she said it. Point, 2 for Kylie. Keep going, Kylie.
So then I found the displacement from 4 different places. But since you just need the distance, it doesn't matter that it's negative, if you need to know how far it traveled, so I changed it to a positive and then add them.
And what does it help me? Thank you. 2 more for Kylie. Anyone want to talk about that? Again, if this feels simple, that's exactly what I want it to feel like, is that it's a simple idea. But I just want you to make sure you're making sense of the idea, just not doing what I'm doing. So, questions on understanding that? Well, hopefully.
Will distance ever be negative?
For our class, they will never consider the distance traveled as a negative. It will always be as though you actually have an odometer in your hand, and it's like measuring how far you go. And so it never goes backwards. Yeah. 2 points. Anybody else? Awesome. Okay, back to Charles's comment, because it was so well stated. These 3 different numbers that all say miles have one meaning. This number that says miles has a different meaning. This number that says miles has an even different meaning. Okay? Question? These are specific locations. This is like, hey, from here to here, that's how different the 2 positions are. And this is what, like, I don't know, I think of this as like the length of a string. Like I start here and I have a string. As I go this way, I let out some string, right? I get to here, and then I just keep letting out string. Then I measure the total length. So it's the length of my path. Okay? And it can go back and forth. Question? Another one is, how many have seen those, this is probably, string's kind of, there's a better one. How many have seen the little walking odometer, like walking tape measure thing? Like it's a wheel on the end, like you use it in track and stuff all the time, right? Like it's a wheel on the end of a stick.
Yeah.
You just walk like this and it measures.
Yeah.
That's distance traveled. Just walking and measuring. So, okay. Question? Awesome. Okay, next thing. Let me copy this. Okay, so we figured out let's do this, hold on. Okay, so we've talked about how you can find this. Oh, you need to memorize this word as well. On the AP test, they don't always use the word displacement. They sometimes use the word change in position. Memorize that. Whether you see the word displacement or you see the phrase change in position, same thing. Question? Okay, cool. We've talked about how displacement can be calculated by knowing the 2 positions. There's another way to calculate displacement. So, if I say, now we're going to make some assumptions here. The assumptions aren't always true, so don't assume that they will always hold, but for this discussion, this is what we'll assume. We'll look at the table that's on your buff sheet, and we'll just assume that from time equals 0 until time equals 5 minutes, for that entire 5-minute time period, we'll assume that the velocity of the plane really is 7 miles per minute. So it's never changing, it's just always 7 miles per minute for those entire 5 minutes. If that's true, then all of you should be able to tell me what is the displacement of the plane, like how different is the plane's starting position from its final position for the time period 0 to 5 minutes. Like work together, raise your hand when you have it. Using only the data in the table and assuming that for the first 5 minutes the velocity of the plane is always 7 miles per minute. What is the displacement of the plane for the first 5 minutes? Hands, come on. Talk to each other, it's fine. What will the displacement of the plane be for the first 5 minutes? Be careful how you say that. Hey, look up. Hallie gets a ticket for saying a really important thing. No, it's really good. Listen. Hey, be careful with the words you use. You really don't want to say how far does it travel. That can get confused with distance travel. In this case, they're the same, but they're not always. That's why it's kind of a lot to say, but you're really looking for how different is the initial position from the final. Distance traveled is different. We don't want to confuse them. Like how far it travels, that could be different. But displacement is always the same thing. Like how different is the location this time versus this time? So who knows the number here? What number goes here, Dawson?
35 miles.
So Dawson said, my position is changing at a rate of 7 miles every minute. And if the plane's position changes at this rate for a total of 5 minutes, then multiplying these two values will tell me by what amount is my position changing during those 5 minutes. How many knew it before he said it? 0.2 for Dawson. You want me to talk more about it? Okay, so we've discussed two different ways to find displacement. We showed here that we can find displacement by simply comparing our locations. You know, how different is the final location from the initial? But we also showed here that we don't have to even know the positions. Like this computation is not talking about anything about position. We simply have to know the rate at which the position is changing and then how much time elapsed. You want me to talk more about this? So everybody do this one now. I'm going to make the same assumption. We're assuming that in the table, from time 5 to time 10, we're going to assume the velocity is always 9.2 miles per minute. So on your notebook, talk to each other, use your calculator, figure out the displacement from time equals 0 to time equal 15 minutes. Go. Yes. Listen to Sydney, please. Hey, 2 points for Sydney. For the purposes of this computation, again, this is not always true, so don't say this is always true. But for the purposes of this computation, we will assume that for the first 5 minutes, the velocity was always 7 miles per minute. Then for the time between 5 and 10 minutes, the velocity is always 9.2, et cetera, et cetera. Go. Feel free to use your calculator.
He did. He wants to talk to one of the also
Hey, look up. Look up, look up, look up. Okay, Elaine is doing exactly what everyone needs to always do. Like, you just pay attention to what your brain is telling you. If your brain is saying, wait a minute, something here just isn't connecting. Like, it's just, you can tell when you're not understanding. You just have to be able to talk about it. That's why I tell people all the time, to succeed in this class, all you have to do is pay attention to when your brain is saying this doesn't make sense, and you just got to find time to talk to me. See if I get this right. The way Elena was thinking of it is, here, it's a really good question. Here, we're talking about displacement, but we're talking about displacement in terms of different positions. We're saying, oh yeah, easy, look. You know, if I know I started at a location of 10, and I stopped at a location of 200, ended up here, then my displacement is 190 miles. I'm just comparing positions. Okay, here, let's get the whole room to answer this. We are no longer talking about position, really. I mean, we're talking about a velocity and then an amount of time. So we didn't use position at all. Hands up. Did the meaning of displacement change? Is the meaning of displacement here different than the meaning of displacement here? Hands up. Who knows? Is the meaning of displacement different in the two examples? Hands. Come on, hands. Who knows? Is the meaning different? Okay.
I feel like it is.
Talk to me.
Because in the last one, we kind of had a, like, we're not dealing with miles per minute in the last one. And this one, we're dealing with different miles per minute, like different velocities between the times.
Let me say something back to you. 3 points for a good answer. Here, we're definitely dealing with just positions, certain numbers of miles, like locations, like Charles said. We're looking at like this location compared to, you know, this location. Absolutely. And then here, we're suddenly just concerning ourselves with miles per minute and miles. It feels very different. However, the meaning hasn't changed. The meaning of displacement here is exactly the same. Come on board. The meaning of displacement here is exactly the same as the meaning of displacement here. How many of the meanings were the same? 2 points. Josh, you had a comment.
So yeah, I just kind of was thinking about this in the way that, like, displacement, like in the first one, was just like one secant slope almost. So you just have like 2 points and you need to find the distance, like find the distance almost. And then with this, you have like different secant slopes, kind of. I don't know if that.
So part of what you, so I like what you said. We want to change the wording just a little. This technically isn't anything to do with secant slope here, but it feels like it because we're going from one point to another. So it isn't secant slope, so don't do that. But to notice that we're going from one point to another is totally valid. And it's a displacement. It's how different is one point from another. And then here, we're still finding displacement. We're just doing it in a different way. So they are both displacement, they're just being done in a different way. We're saying, we don't actually have to know the positions. Because okay, listen, look, this is super good. Look at me. It's the key words here. Displacement is how different is my new position from the old. And I can find that by knowing both positions. Or I don't have to even know the positions at all. I just need to know, how is my position changing? This tells me how my position is changing. It says every time a minute goes by, my position is 7 miles more to the right. And so if I know how much time goes by, I don't have to know where I was at all. I can tell you my position changed by this amount. That felt better, right?
Yeah.
Yeah, you could pretty much see it in your face. Good. Is that okay?
Yeah.
Does that help? 3 points for, I already gave you a ticket, never mind. 3 more, write them down. Okay, please.
So about 7 miles is the tangent slope, not the secant slope.
Hey, look up. Look up. The 7 miles per minute actually could be either, so we don't want to really worry about it for now. For now, don't worry about that. For now, just make sure it makes sense to you that we're saying this is the rate at which my position is changing for the entire 5 minutes. Whether it's secant or tangent's a bit more complex, so we won't worry about that for now. Please.
Just give us like a point, so at 5 minutes, it's 35 miles.
Say again.
So since we did, because we have the velocity, which is 7 miles a minute, and then times by 5 minutes, that gives us a point, so we know at 5 minutes, it's 35 miles from the origin.
Oh, hey, this is awesome. Look up. Hey, 3 for Justin. Look at me. Look at me. Okay, key thing here. It doesn't matter whether what you said is right or wrong. What's important is that everybody, not just Justin, everybody understands whether it's right or wrong. Okay, so start with that. 3 points for Justin. He said, this is saying that at time equal 5, this is the location of the particle. Hands up if you know whether that's true or false and why. This is saying that at time equal 5, this is where the particle is located. Hands up, true or false, why, why not? Come on. Time equal 5, this is where the particle is located. Hallie?
It's false because it could have started at, like at t0, it could have started at 10. So you traveled 35 miles from 10, so it could be at 45 instead.
Perfect, 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 perfect. It's back to what Elena noticed. This computation has no reference to where the particle is. It only references how much the particle's position is changing. So this is not a location. This is Charles's thing. This is one of these. Yeah, this is a difference between 2 locations. It's not. This is really good. Like, getting me all excited here. Please remind me not to hit the board. I told you the story, right? Yeah. Okay. I need your help to remind me. I get kind of carried away. Yeah, it's not a good idea, I promise. Don't ever do it. Don't ever think to yourself, I wonder what that will feel like. You will regret it for about 6 weeks. Don't do it. But don't be like my, 18-month-old grandson when you're trying to explain, it's hot, don't touch. So then they just reach out and touch again. Hey, come on. Focus, come on, help me. No, I really like what Charles did. In the previous example, we said the position at time 0 was 10. Okay, this is one of these things, right? This is like a specific spot. This, no, this isn't this is this. Do you hear the difference? Awesome. The video's not working because I can't see my hands, but whatever. Questions? Awesome. So, hands up. Who knows what goes here? Come on, hand. What do I write here? Hands, hands, hands. What should I write here? Come on, you can do it. Yes. What should I write here? What gets written here? Julia.
45.
How many knew it? 0.2 for Julia. Okay. You're good. Very good. Okay, back to this one.
I'm gonna put you in a kettle that's made of metal.
Ashley, you. What's that?
I think, keep going.
Just talk to me a little bit.
Well, I was looking at the velocities, like, I don't even know why I was doing that.
No worries. No worries.
Not even part of that question.
No worries. Hey, one point of encouragement. Everybody, look here, look here. If, as we discussed, if your brain is engaged, like you're thinking, you're trying to think ahead of me, you're trying to think like me, and if you suddenly take a wrong turn, it's like, whoa, that didn't make any sense. It's okay, don't worry about it. Just keep making sense as we go forward. So if we do if we talk about it and you still don't get it, then you got to make sure you speak up. But you've been really good about that all year, so I trust that you'll speak up. Is that fair? Okay, good. Hey, no, listen. Look, I don't know, maybe you know this, maybe you don't. Okay, the number of students who take calculus at Lone Peak and who pass the test, I tried to get data on the whole state, and it was hard to get, so I kind of gave up. But compared to the rest of the district, no, you should all be proud of this. Listen, the number of students who take AP Calculus and then who succeed by passing the AP test is typically double to, sometimes it has been triple. Like there have been years where like 3 times as many, almost, okay, as other schools. Like the closest school is like half, and then it drops off a lot from there, okay? Here's why, listen, look at me. No, listen. Not true. But here's what I believe strong. Look at me, come on. Eyes here, look. Okay, here's what I really believe. I believe if you just take the time to talk about it enough, it's like what I was telling to Ashley. Look, if you just take the time to talk about it, like you tell me when it doesn't make sense, like Elena did, and then you're willing to be patient, just talk about it, you can make sense of it. What happens at too many schools, I know I'm criticizing, but I just believe it strongly. Just people just won't talk about it enough. Like they explain it once, if you don't get it, like, oh well, your problem, not mine. Okay, your job, you have to tell me when it doesn't make sense. That's it. My job, try to say it in a way that will make sense. If it still doesn't, then you have to do what Elena always does. You just look back at me and go, nope. And then we try to say it in different ways. That's it. That's all you got to do. Okay. Question. Do this. Go. Come on. Find the purple. You've already found it. Just wait a minute. So let everybody catch up. Find the purple. Go.
Was you finding what this
And just taking karate. You said you would ask.
Everyone's saying it too.
Maybe pictures. If you're doing
Hey, look out. Hey. Hey, look. Sarah. Hey. Sarah, listen. Sarah brought up a really good comment. I want all of you to answer this question. She asked, and she thought about this. She thought that maybe what we should do is say, well, at time equals 0, I've got 7. And then at time equals 15, I have 7 again. Ignore that for a second. Answer this question. I told you earlier to memorize a phrase that means exactly the same thing as displacement. Who knows the phrase you should have memorized that means exactly the same thing as displacement? What's the phrase?
Change in position.
Okay, so displacement also means change in position. So I'm asking you to find, this is a really good discussion today. I'm asking you to find the change in position between these two times, like from the time 0 to time 15, by how much did the plane's position change? If I do this, and I get this, I am finding something of value. What am I finding? Hands, come on, hands. What is this finding? Come on, hands, you can do it. Just think about it. Like, again, the idea here is not to do what I do. It's like get understanding of thing. What is this finding, Calvin?
You find that there's no change in position.
2 points, but no, it's okay. What do we find? It's close. It's close. No, look. Hands down for a second. What I'm trying to get all of you to do, look at me. You all have the same habit. You've taken so many classes where all you had to do was mimic what the teacher did. That's the habit you have. And so you're mimicking. You're saying, well, here I took these two numbers and subtracted them, and I got 190. So that's what you do. So over here, I guess I'm supposed to go, let's see, time equal 0 to time. I'm supposed to take these two numbers and subtract them. That's not what I'm asking, but you do find something here. What are you finding? What are you finding here? What's being found, Sophie?
Change in velocity.
This is the change in velocity. Okay, how many knew it? How many knew it? Come on, hand. 2 points, 3 for Sophie. Okay, look. So it's really awesome. It really is. I'm really glad that this got brought up because it's good for you to see the comparison. This is finding the change in velocity. Between these two times, the velocity does not change. Now it does, like it's different things in between, but when we ask for change in velocity, you're not supposed to concern yourself with what's happening in between. It's just comparing beginning to end. Please, Justin.
So say, instead of that saying miles per minute, if that just said miles, would that then become change in position?
Right, because this would not have been a velocity, it would have been a position. Okay, I said that in this unit, come on, focus, 2 for Justin. Look at me, come on. This is what I mean by, this seems like a simple discussion, but little things can really mess you up, so you gotta get it really clear. Okay, in this unit, paying attention to the units makes a huge difference. So just say it out loud, please. What are the units of this number? Say it. What are the units of this number? Miles per minute. What are the units of this number?
Miles per minute.
So when you subtract miles per minute from miles per minute, what units do you get?
Miles per minute.
Miles per minute. So this is not a change in position. This is a change in velocity. It's saying how much did the velocity change during that time period. We want to talk more about what this is.
Wait, how do we like kind of disregard the 9.2 and the 9.5? Like it increases and then it goes back down to 7. So
Keep talking.
what happens to that?
Okay, listen close to Sydney's question. Okay, your logic is really good. So have confidence that you have very good logic. It's simply the definition of the word. So when they say they want to find the change in velocity, they're telling you to ignore whatever happens and only compare what was with what is. Does that make sense? So your logic is perfect. That's just not what they're asking for. That's all. Is that okay? It's perfect. Okay, cool. Who has the answer to the purple? Hands, come on. Who has an answer for the purple? Let's go, Tori.
128.5 miles.
So tell me what you did to find this. Like, what are the numbers you did?
So I did from 0 to 5 minutes. I did so I did 7 miles per minute times 5 minutes, and then 9.2 miles per minute times 5 minutes. And you're adding those two together. And then I did 9.5 miles per minute times 5 also, 5 minutes.
3 points for Tori. Just let me get this written here. $128.5, Tori.
Yeah.
Okay, remember, pay attention to the units. These minutes divide out, these divide out, these divide out. So just add it up, you get miles. How many got this number before she said it? How many had it? 2 points, 3 for Tori. Question? Okay, the big idea is, hey, this isn't clicking, just keep talking to me. Look, Sarah, better. Look. Okay, what we're trying to show is 2 different ways to determine by what amount is the position changing. One way is to simply compare position. Okay? Other way is to know the rate at which the position is changing. This says every time 1 minute of time elapses, your position will be 7 miles to the right of where it was. So that continues to occur for 5 minutes. This is going to be a total of 35 miles that your position will change during those 5 minutes. Then because, as Sydney said, the velocity is different for the next 5 minutes, your position is going to change at a different rate. So we calculate this number. And then same thing here, we add them all up, we get the total change in position.
So when I first looked at the table, I thought like the difference in velocity of light. So like, how come does it just go from 0 to 5? It's all 7, or is it like increasing over time?
Gotcha. So because it's a table, we actually don't know. So what I said in the beginning was we're going to, for this example, assume something that's not always true, but for now we'll assume it. We'll assume that for the entire 5 minutes, the velocity never changes. It's always 7. So we're assuming the impossible, which is the plane has a velocity of, like, you all need to ride in a ride like this. Like, it would be unbelievable. Like, it goes 7, like, awful is the right word, actually. Like, no one knows what this feels like, I promise. Because you can't do it. No, you can't go 7 miles per minute and then suddenly jump to a speed of 9.2 miles per minute. The acceleration is unbelievable, impossible. Like, it would kill you. Like, your body can't do that. Actually, it's acting it out. Oh, it's perfect. Except the jolt is way more than that. No, it's awesome. Hey, listen. Anyway, so Josh, so yes, we are just, for the purpose of making the discussion not too complicated, we are assuming the impossible. Okay. Welcome to school. That's what we like in school. And you get a real job, like, oh yeah, forget.
Like, wait, actually.
You don't forget, you just have to add to it. Hey. Okay, questions here. Okay, look. Okay, the title of Matt actually asked Josh's brother. He asked for a title for Unit 4. Okay. He asked for a title for Unit 4, and titles don't really matter, but I don't mind sharing. The title of this unit, the title I gave it, is Integration with a Calculator. That implies that we will also study integration without a calculator, but we'll start with. Okay, the word integration. If you have studied, okay, look, I need all of you to forget some things you may have learned in a physics class and or from a sibling. Because, in my opinion, most people, when you talk about integration, most people initial learning of this is wrong. And my initial learning of this word was also wrong, and it really got in the way of me understanding it. Like, I struggled for years to understand what this is. Okay, so I'm trying to start you off correctly so you won't have the same struggle. Okay? Integration is just a mathematical process. It's a really simple mathematical process. It is basically illustrated here. This is integration right here. Integration is simply a combination of multiplying and adding. Look what happened. We multiplied two values, multiplied two more, and then we added them together. Okay, you should memorize right now that that's what integration is. Integration is simply the multiplication of two values, and then another two, and then another two, then you add them up. Like, there's a bit more to it, but that's where you should start. Okay, just forget what anybody else has told you, what else you've learned in some other class. Integration is multiplying and adding. And if you can, in the future, find some sort of problem that needs solving, you're like, oh, I know what I need to do. I need to like multiply and add a whole bunch of times. You're like, oh, I need to integrate. That's integration, okay? It's not whatever else people have told you, in my opinion. It's just multiplying and adding. That's it. The symbol for integration looks like this. Okay? Okay, look at that symbol and try to imagine that what you see, my drawing isn't the best, but what you see is the letter S that has been elongated. Like you take an S and you stretch it. Can you see it? Okay. Look at what I told, come on, just a couple more minutes, focus. Like, no homework tonight, by the way. Please do not do anything in the buff packet. Look at me. Please do not do anything in the buff packet. Wait. Okay. Half of this class is all about integration. So now into the second half of the class. It's all about integration. But if you can just get the fundamentals, you'll be fine. But if you start getting ideas that aren't really on track, you're going to have trouble. So don't do anything. So look here. Look. I told you that integration is essentially multiplying plus. This is a big S for a reason. You can't see the connection, don't worry about it. But look here, look at what we're doing when we do integration. Anybody have an idea what the big S stands for? Like, this is integration. Multiply, add, multiply, add. Anybody know what the big S stands for? Hands. Got 90 seconds. It relates to doing this. You take this plus this plus this. Everybody's like going, something. So somebody said sin. It's not sin. What's S? Say it again. Okay. Anybody else know? Ken, anybody else?
Did we know?
Hey, look.
Oh, slow.
Listen, hey. Hey, no, look. That's why I say if you learn it correctly, it's simple. I never knew that for years. Okay? It's just a big S. It stands for sum. You're going to add these up. Okay? Bell's going to ring. Well, stay with me. Look. Here's the rest of the symbol. Look, come on, look. Here's the rest of the symbol.
Oh, whoa.
Yeah, we'll talk.
I like slow. I like slow.